Grade 11s, welcome. Finally, it's your turn. Maths Lit Learn Extra live. And we are live indeed. Joining us today is Peter, tomfoolery of note, and I'm sure you're going to have a fun time. Peter, why don't you tell us what we're talking about today?
All right, before I discuss what we're talking about, how was Valentine's Day for you?
It was okay. It was an okay. I wonder if my boyfriend's watching. It was an okay Valentine's. Okay, it was fantastic.
Mine was superb, hey? Got a fantastic wife. Opened up my lunchbox. There was chocolates and hearts. It was just really good.
Cute.
But there was a little message, and it kind of confused me.
Yeah.
Because it said, "I thought I could love no other until I met your brother." I think I'm worried about that.
I think you should be worried. Well, while Peter has a little cry on my shoulder, let's take a little break, and we'll be back shortly. See you after the break.
Cheers.
Welcome back, grade 11s. I hope you're all sitting on the edges of your seat waiting for this fantastical lesson. If any of you have watched pizza before, you guys know that you're going to, first of all, learn a lot, but second of all, probably laugh a lot too. So let's get learning, let's get laughing. Peter, take it away.
Well, I don't know how much laughing is going to take place today, because I'm still quite hurt about my poem that my wife sent me. I thought I could love no other until I met your brother. So I'm really worried about that. And during the ad break, Indiana actually explained what that could mean. So I think straight after the show, I need to get home and give my brother a call as well and see where he is and where my wife is. It's kind of disturbing, isn't it?
It's a bit strange. I think you should.
Okay,
but don't leave now, because we need you now.
The only thing that made me feel better about the whole thing was that during the ad break, I saw one of the cards that Indiana got, and it said something along the lines that, "Every time I see your face, I wish I were in outer space." Well, that's kind of scary. I'm glad I didn't get that card. But folk, we're here for Maths Lit, and that's what it's all about. So let's get excited and let's look at our topic for today. Our topic for today is ratio, proportion, and rate. Okay, now we tend to look at the three of them, the ratio, the proportion, the rate, and sometimes we kind of think it all fits into one and it means all the same thing. So I thought what we do today is we're going to start off today's lesson looking at the definition of ratio, and then looking at saying, well, what does proportion mean and what does rate mean? And then after looking at all that, we're going to look at a few examples, because you know what I always believe? I always believe the best way to learn is by doing some examples. Let's look at ratio. So what does this whole thing of ratio actually mean? Well, a ratio is a comparison of two numbers called terms of the ratio. Ratios have no units, since the quantities being compared are of the same kind or type. Ratios can be written in different ways. And before we look at those ways, then let's just put this whole garbage that's written on the back of me in some form of English. Okay. So a ratio is when I take two things that are the same quantity. In other words, I could take two sets of human beings, like boys and girls, and compare the ratio. So if you were to look at your school and you would say, what's the ratio of boys to girls? And someone might say, well, the ratio of boys to girls is 3:2. In other words, every 3 boys that there are at the school, there are 2 girls. Okay? It also means then that for every 30 boys in the school, there are 20 girls. Geez, now how did we suddenly jump from 3 to 2 and suddenly jump up to 30 to 20? We'll talk about that later. Now, how can we write ratios? Well, there are 3 ways. We can write them in words. For example, A to B, or boys to girls. We can write it with a colon. A dot B. Okay, so earlier on I said to you that if we were to say boys to girls, we could say there are 2 boys, to 3 girls. Okay, great, let's just get rid of that and write it 2 properly. With a colon, we could say my ratio is 2 to 3. And then as a fraction, we could write a ratio as 2/3. But the most common one that we use, and the most common way of expressing it in an examination, is with the colon. In other words, it's this method over here. That is our most common. That's the one you're going to see in an exam over and over and over again. That's the one your teacher's going to probably place a lot of emphasis on. That's the one when you open up a newspaper, you're going to see the ratios written like that. When you open up a geography book and you see the ratios in a map and it says 1 is to 50,000, it'll say 1 colon 50,000. Okay? That's our most common one. That's the one that I'm going to use mostly today when I work with problems related to ratios. So let's have a look at an example here. An example. Suppose there are 12 boys and 9 girls in a class. The ratio of boys to girls can be written 12 to 9, 12.9, colon 9, or 12 over 9. Okay. So we are always comparing the same thing. I cannot suddenly compare apples to children that are born. So I can't say for every apple that hangs from a tree, 3 babies are born in the hospital. There's just no link at all. Okay? So we've got to make sure when we deal with ratios that we can compare the two. Cool? Let's move on. The next thing now we're going to look at is proportion. So what is proportion? Well, proportion is a comparison between two ratios. Now, if I were just dealing with a ratio, I would probably only look at one part of this whole proportion. So I'd look at 3 over 12 and say the ratio of boys to girls is 3 is to 12. When I deal with proportion, okay, I'm now making a comparison from one situation to another situation, but still dealing boys to girls. So if we were to look here, I would say the ratio of boys to girls is 3 is to 12. In other words, for every 3 boys, I have 12 girls. Well, what happens then if that ratio is the same, but in one case, I now have 6 boys? Well, how did I get that 3 to 6? I multiplied by 2. So what am I going to do with the 12? I'm also going to multiply it by 2, and I'm going to get 24. Now, folks, at this stage, I must stress this, that this lesson is for grade 11, and dare I add this a grade 12. Okay, because remember, grade 12 is a build on from grade 11. But although this is a grade 11 lesson, a lot of this work was done last year when you were in grade 10. And that's why I'm just presuming that you understand that 3 over 12 is exactly the same as 6 over 24. Okay. Now, let's have a look at an example where we use proportion. Let's say that you want to mix cement to patch a crack in the wall, and have noticed that the builder mixes 7 pockets of cement with 21 pockets of sand. If you decide to mix 3 cups of cement with 6 cups of sand, are you using the cement and the sand in the same proportion as the builder? Right. This is like such a real life example. Okay? We had work done in our house, and what actually happened was a group of builders rocked up and they actually mixed cement. And what they did was they actually took 7 pockets of cement and they took 21 bags of sand and mixed it all together and made this phenomenal actual bit of concrete, as it were. And with that, they could build and use it for patching our driveway and putting bricks down and making sure the cement held the bricks in place and everything. Now, my little boykie was watching this, and he was thinking, aha, for every 7 pockets of cement, they put in 21 pockets of sand. Now, I just want to point something out to you here. This is pockets. This is pockets. Notice we're making a comparison, pockets to pockets. Okay. When the builders left, like all boys, my little boy, he climbed out to the building site, as it were, and he suddenly said, I'm also going to make some concrete. So he got a bit of cement and he got a bit of sand. And he said, well, what they actually did was this. They used 7 pockets of cement to 21 pockets of sand. Right. And then he very cleverly, and he would be because he takes after his dad. His mom didn't fit into that part of the genes at all. No, I'm lying. I love my wife. She's very clever. She was, because she got as a husband. But anyway, so that we could break down as a ratio of 1:3. In other words, for every 1 bag of cement, we're going to put 3 bags of sand. Okay? And the builders, I mean, if you look, it makes sense, hey? Because 1 times 7 is 7, 3 times 7 is 21. So my little boykie said, right, let's do the same thing. But he didn't want bags of cement. He just wanted to make a little bit of cement. So he ran into the kitchen, got my wife's finest chinas, and got one of the cups from that china set. Okay? And he ran outside, and what he did was he took 3 cups of cement. Oops, let's try that again. 3 cups of cement, and then he got 6 cups of sand. And he tried to make the same kind of mixture. And he kind of got it right, but it wasn't quite the same texture as what the builders did. And I wonder why. Let's have a look at this. If we were to look at this ratio, 3:6, and we were to simplify it, we could say, well, how do I get that 1 to be a 3? Well, I divide it by 3. I say 3 divided by 3 gives me 1. So what do I do with the 6? The same thing. I'm going to say 6 divided by 3, and I get 2. So look what happened here. The builder used a ratio of, for every 1 bag of cement, we're using 3 bags of sand. Or, for every 1 part of cement, we're using 3 parts of sand. My little boykie comes along and he says, well, I'm doing it differently. For every 1 bag of cement, I'm using 2 parts of sand. Can you see there's a difference? So the texture is not going to be the same at all. So from this whole experiment between the builders and my son, we came up with this question. If you decide to mix 3 cups of cement with 6 cups of sand, are you using cement and sand in the same proportion as the builder? That's the question. The answer must be, no, you're not. For the very reason that I explained. Okay. Now, the one thing that's so important about ratios is simplifying them, getting them as simple as possible. And I'm going to show you how. You're going to use your calculator and you're going to cheat. All right. So let's look at it like this. Here I've got a ratio 7:21. Watch carefully now. I'm going to bring up the calculator and I'm actually going to type 7:21. But remember, a ratio can be written in the form of a fraction. So I'm going to say 7/21. Okay? If I push equals, this calculator, if it's working properly, should give me an answer of 1:3. Let's see what happens. Drum roll and voila. Here's my answer. 1/3. So 7/21 is the same as 1/3. But folk, listen carefully. If your teacher or the examiner gives you a question and it says 7:21, oops, let's just get a bit of writing here. 7:21, and you've now used your calculator, here's your answer. You cannot now say, oh, that's easy, my answer is 1/3. Okay. Why can't I do that? I can't do that because my examiner's written it in the form of 7:21, and I must give it back to the examiner in the same form. Okay? 1:3. So 7:21 is the same as 1:3. Even though your calculator simplifies it always as a fraction. Does that help you? It should, hey? It's very easy. Let's say I give you the ratio of 54:60. Okay, so we're just making something up here. 54:60, and you've got to simplify that. Because in matric, and I know you're in grade 11, so it could come up in your grade 11 paper, and it could also come up in matric. We might give you a question where we say 54:60. Simplify your answer, okay? Or simplify the ratio, rather. So what we do is we go to our calculator and we say, okay, I remember watching this guy on TV, and he pushed the fraction button. He pushed the first ratio over the second ratio, pushed the equal sign, and voila, there I have 9/10. So the simplest way of making 54 over 60 is by saying it's actually 9 is to 10. Okay. Guys, you see how your calculator makes life so interesting and makes life so easy. It's absolutely basic. Got to use that calculator. You paid money for it, use the thing. And I always say that to my students. Even if you're adding 1 plus 2, you know, when you're writing an exam, you're under a lot of pressure, a lot of tension. There was a woman here on Monday, okay? Fantastic lady, very, very bright. I wish I could have half her brains, okay? And she came up with a problem, and she was battling with this board on Monday. I saw her. She was under a lot of pressure. And all she could think of was, oh, I hope I'm getting this board right. I hope this board doesn't go off. And she was really, really worried. And then what she did, she came up with a problem that said 24 minus 5. Do you remember that, Indiana?
I do.
Okay. And she couldn't think of the answer. And here is an experienced, phenomenal mathematician. But she found herself under pressure and suddenly said 24 minus 5, and she wrote down the answer. And it was wrong. It was 18. Now, I know this lady very well, so I haven't stopped teasing her about it at all. Because we all know that 24 minus 5 is?
Well, I was going to say, teasing her in true Peter style, hey?
No, absolutely.
19, obviously.
Okay, Indiana, back in the question. What's 24 minus 5?
19.
Absolutely. Okay. So we all know it's 19. But she was under such pressure. So this is my point to you. My point is quite clearly this. When we're under pressure, we make silly mistakes. When you write your exam at the end of the year, especially when you're in matric, you're suddenly going to come across things. We all know that 24 minus 5 is 19. But when we're under pressure in the exam, we go, oh, careless mistake, 18. Okay? Use the calculator. When we're simplifying ratios, we're going to use our calculator. Okay, let's look at another example. Okay, I think I've just doubled back twice here. The next thing we're going to look at is rates. Now, what is a rate? Well, a rate is a special type of ratio. For rates, we compare two different quantities. For example, the cost of petrol per litre and the distance travelled per hour. Now, you will remember that in examples we've looked at how many bags of cement, how many bags of sand. The units are the same, they're bags. Or like my little boyki did, number of cups. Okay? Here we deal with different quantities altogether. For example, the cost of petrol per litre. We could say the cost of petrol per litre, I don't know, I've forgotten. What is the cost of
really,
litre?
really expensive. I actually have no idea.
You just fill up your car and go.
I know that my car takes about 400 rand to fill up. So how many litres is that?
I don't know how many litres is your
I think it's
tank?
9 rand a litre, roundabout.
That. I think
Yeah.
you're totally and absolutely wrong. It's round about 10 rand. So we can say petrol is round about 10 rand per litre. Now, with rates, we normally have the word per, which is P-E-R, not like a cat, P-U-R-R, but per litre. So 10 rand per litre, but instead of writing the word per, we just put a slash. Okay? Can you see I've got two different units? I've got the R for rands, and I've got the L for litres. So we're dealing in rands and litres, but we're making a comparison between the two. But because the units are not the same, I'm now not calling it a ratio, but now it's rather a rate. Okay? So many rands per litre. Another example, distance travelled per hour. Okay? Now I really, really hope my mother-in-law is watching this, because when we look at distance travelled per hour, we sometimes get this called a speed limit. And it's called 60 kilometers per hour. All right? Which means, mother-in-law, that if after traveling 1 hour, I should have completed 60 kilometers. If the speed limit, mother-in-law, is 60 kilometers per hour, it doesn't mean I should be able to do 140 kilometers within that hour. There's something wrong here, okay? The foot's a little heavy on the petrol. So 60 kilometers per hour, notice we've still got per, and notice our units are different. I got kilometers and hour, and I'm making a comparison between two different units altogether. Okay? So rate, comparison between the same unit, cups and cups, or bags and bags, or people and people. Okay? Rate, rand per litre, or kilometres per hour. Do you understand that, Indiana?
I do. Do you mindsetters understand that? Let's ask the mindsetters. Guys, if you don't understand, send through your questions and let us know where you're not understanding. And I think we should take a short break.
Do you think so?
How do you feel about that?
Well, I was just thinking, if you understand, then I know the viewers will understand.
Yes. Well, then they all understand.
Well, that's
then we don't even need to. Then we don't even need to go there. Then.
Okay. But you still want the break?
Yes. Let's take a short.
Does our producer want the break?
The producer wants a short break.
Let's
have a short break. We'll be back with you shortly. Bye. Welcome back, Mindsetters. Hope you're having a fantastic lesson. I know I am. I'm learning lots, which means that, like Peter said earlier, you are learning lots. So Peter, let's get straight back to it. And yeah, let's go, guys. Hope you're all excited. Get chatting to us on Facebook and Twitter as well. Yeah.
Absolutely. All right. Please talk to us, because then we know if you're understanding or if you're not understanding. Before we start with the questions, though, just one little Valentine's poem. Okay?
Oh, another one.
Another one. Here we go. Roses are red, violets are blue. Most poems rhyme, but this one doesn't. Okay, so let's move on. Futsi is opening a frozen yogurt kiosk at his local cinema. He's bought a chest freezer for the kiosk. The freezer is 150 centimeters wide, 80 centimeters deep, and 160 centimeters high. Use the formula V is equal to L times breadth times height to calculate the capacity of the fridge in litres. If 1,000 centimeters cubed is equal to 1 litre. Yay! Now I know exactly what you're asking yourself. You're saying to yourself, myself, I thought we're dealing with ratio, rate, and proportion, and now suddenly there's this huge shape and measurement like volume question coming up here. But guys, wait, it's going to be revealed shortly, okay? We're now mixing up a little bit of shape and measurement with ratio and rate. So let's have a look at this, okay? So, volume. We know that to calculate volume, we are going to say my volume is equal to the length times the breadth times my height. And I'm going to now put certain of these numbers into my formula. And remember something, guys, in a maths lit exam, if they give you the formula, you're going to have to use that formula. If you don't use that formula, then something's wrong. You've gone astray somewhere, okay? And I say this so often, and I'll say it again. Why? Because I want to. Examiners and teachers don't wake up at 2 o'clock in the morning and think, oh, I've got a test for my guys. I know, let me just think of some random formula here and throw it into a question.
Don't lie, that's exactly what they do.
No, not maths lit teachers. Hey? Maths teachers, horrible. They always do that. Maths lit teachers, we're loving, we're caring, not just on Valentine's Day, every day. So if we give you a formula, that's the formula you're going to use. So looking at this now, volume is equal to length times breadth times height. What is my length? Well, we've got something 150 centimeters wide, 80 centimeters deep, and 160 centimeters high. We'll say our length now is going to be 150 centimeters times, now I must say this, I feel a little bit sorry for my producer because they typed this out and they've said it's high and it's also deep. Now to me the height and the depth is the same thing. So we'll pretend that my producer meant to say so long, so wide and so high. Okay? So we're going to say it's 150 centimeters times 80 centimeters multiplied by 160 centimeters. So let's find this out on my calculator. We're going to say, right, we got 150 multiplied by 80 multiplied by, what was the third digit, Indiana?
Oh, I wasn't paying attention. I'm sorry, Peter.
Okay, there it is, hey, 160. So it's 150
so save that answer for you, Peter.
80 by 160 equals, and my answer, yes, that's a big number, hey? 1, 2, 3, 4 noughts and 192. So we're going to say, right, it is, when we get a pen, here we go, it is equal to 192 and 4 noughts.
Should I save that? Just
Save
in case.
Put it on your computer.
Okay.
We might come back to it. Okay. Now it's equal to what? Well, it's going to equal to centimeters cubed. Why? Because we had centimeters times centimeters times centimeters. Now it's very naughty. I didn't put in the units, but we do understand though that this was centimeters, hey? And this was centimeters. I'm not managing to fit it in here. Centimeters. So it's centimeters times centimeters times centimeters. I've multiplied the centimeters 3 times. So I have 1,920,000 centimeters cubed. That's the capacity of this deep freeze that Vusi has bought. But the question is this: what's the capacity in litres? Now, folk, if we look here at our question, it says quite clearly that 1 litre is equal to 1,000 centimeters cubed. So it stands to reason then that what I'm going to do is I'm going to take my answer that's in centimeters cubed, divide it by 1,000 to get the number of litres. And when I do that, I'm going to land up with 1,920 litres. Okay, so that's how many litres I could have in my fridge. In other words, if I got a bucket and I filled it with water, I could keep pouring into my deep freeze, pour this water in, until it's full. And when it's full, I would have poured in 1,920 litres of water. Okay? That's how much water this deep freeze can take. Now, obviously, there's another part to this question. So I know Indiana's recorded these results, so we don't have to go backwards.
Oh no, wait. Before you have.
Yeah.
Okay, which numbers can I record for you?
1,920.
Perfect.
Okay.
Litres.
Litres it is.
I have it for you here, Peter,
Okay.
when
So
you need
here
it.
we go now. We've got funny things on our screen, but let's keep going. So, Vusi buys the frozen yogurt in 25-litre containers. Calculate the approximate number of 25-litre containers that the fridge is able to hold. Okay, so I understand now why the person who set this paper actually asked this question, but there's a little horrible trick to this question, which I'll discuss with you just now. So we want to know how many times can 25-litre drums fit into this freezer. Now, do you remember how big our freezer was? How many litres could our freezer take, Indiana?
It could take 1,920 litres.
Cool. So if it could take 1,920 litres, and I want to see how many 25-litre containers can fit in there, what I'm going to do is basically say 1,920, and I'm going to divide it by 25. Well, I'm not going to do that. My calculator's going to do that. So we're going to say, right, 1,920, divide that now by 25, and voila, I get 76,8. So 76,8 containers. Okay. But let me just say the whole word here so we know what we say. Containers. Okay. Here's the problem though, people. We're not going to go off to a shop and buy 76,8 containers. Right? Because the shop owner is going to be a little bit concerned when we walk in there with a pair of scissors and like a big spoon. And we take our 25-litre container and we take 76 whole ones, and the 75th one we say, wait, we don't need the whole one, we only need 0.8 of it. So we just kind of cut this thing and only scoop off a little bit of it. And we'll walk off and get to the counter, and I tell you what, you're going to have a very, very, very confused lady sitting at the till. She's not going to quite know what to charge you for this, okay? So we can't have 0.8 containers. Now, people, rounding is a most amazing topic. Because normally when we say we're going to round, we say if this digit is a 5 or more, we're going to round it up. Okay. But in this case, we cannot, we shall not, ons moenie this thing up round me. Alright, we can't do that. Why? Because our fridge can't contain more than 76,8 containers. So what I'm going to say is because I can't buy 0.8 of a container, okay, I am just going to fit 76 containers in. The 77th one will not fit in, but 76 will. Yeah, sure, I'm going to have a little bit of space, but that's all right, because the question didn't ask how much space I'm going to have left over. It said how many containers. Guys, it can only fit 76. Do we understand that? Okay. So this particular question didn't ask us to round off to the nearest whole number. So we've just got to understand we got to round. And we can't just round it to the nearest whole number. In this particular case, we've got to round to 76. Okay. It's the same thing if you've got a motor car, right? And you say how many people can fit into that car. You can't say 3,285 people, all right? You can't. You can't say 5,6 people fit into this car because you can't get 0.6 of a person. So only 5 people can. 6 people can't, but 5 people can. So there's no such thing as 0.6 of a person. Now I know you may look at someone and say, yeah, but what happens if a buddy's been in an accident and he's lost his arms and now he's just walking around with 2 little stumpies here? It's okay, he's still a whole person, hey, because the person's within. I know some of us look at Indiana and say, well, you know, is she completely one and all kind of thing? Well, you know, irrespective of the intelligence level, she's still a whole person. So we still can fit 5 people in that car, right? And not 6. And we can't fit 5,8. Do you understand what I'm getting at with the rounding? If you don't understand BBM or S, what do they do there?
Let me tell you. You see, this is my job, Peter. You see, Peter thinks he knows everything, but I only know this side. So, Peter, let me tell you, it's facebook.com/learnextra, and that's XTRA. Chat to us on Facebook. Post the questions on the page, guys. Guys, we will chat back to you, I promise. Yeah. And also, I mean, Danny says, can I post my questions now? Is there no time for that? Guys, there's still time. Get them in. Also, chat to us on Twitter @LearnExtra. And chat to me, because that's what I do during the show. I'm sitting here chatting to you while Peter chats to you on the TV. Okay. So you go ahead. You do your job now.
I'll do my job if you stop talking.
Right. So I shall try.
Now, the next question is, and you remember just now I said there's a funny trick to this question. Here's the question. Will he actually be able to fit this number of containers into his freezer? Explain your answer. Well, geez, that's quite a tricky kind of question. Because if you look at the shape of a freezer, the shape of a freezer is like a box, isn't it? So were I to say this is my freezer, okay, the number of boxes I'm going to fit there will depend on the shape of the actual yogurt containers that I'm putting in that freezer. So if I were to get nice little boxes of yogurt, perfect boxes, and I were to put them into that freezer, well, maybe then I would fit the full 100 and how many containers could we fit?
That was 1,920 liters. Yes. I don't, 76 containers, 8.
All right. So Indiana's with us, and we welcome her back to the program.
Thank you. Thank you.
So I could actually fit in containers if they fit perfectly. But have you ever seen a yogurt container? Okay, a yogurt's kind of round. Now, if I were to look from the top, so let's say I'm looking at the top, and this is my top view. So I'm looking onto the box, in other words, looking down on the box, right? My yogurt containers would fit in, and there would be these gaps over here. Okay, so they might touch here, but they're little gaps all over the place, right? So where there's a gap, I'm losing some volume. So my ice cream or my yogurt is not fitting in perfectly. They're gaps. So will I then be able to fill a full 176 containers? No, I won't. Okay? Because of all the gaps. And our initial question, we pretended that there were going to be no gaps at all. We're going to fit the yogurt in perfectly. Well, in reality, guys, it doesn't always work out. Okay, are you aware of that? And that's a nice level 4 type question, where we now, you've worked on some facts, and now we pose this question. What do you think? Do you think this will work? Analyze this, or reflect upon your answer. And now you're looking and saying, you know what, in real life, yeah, mathematically it might work out, but in real life, yogurt containers aren't square, okay? They're round. And so I'm going to not use all the space in that freezer. Okay.
Fantastic.
Right, let's move on.
Can I ask you a question?
Please ask me a question.
Okay, this one is from Tapang, and I think it's a pretty good one. It said, she wants to know, is the following a ratio or a rate? 186 learners to 6 classes.
Okay, 186 learners to 6
Classes.
Okay. That's a very good question, but you know what? It is still a ratio. Okay, because it's not 186 per 6 classes. Well, I suppose it could be. Hey? You could look at it in both sides. But normally we would say 186 to 6. But I suppose that's a very good question.
Yeah, you see, it's a bit of a bamboozle there, right?
It's a bit of a bamboozle. I would say, you know what? We could actually say that it's a kind of rate, hey, because it's number of pupils per class. So it's 186 learners per class.
So is it a rate or a ratio?
I would go for...
so I'm even a bit confused now.
Yeah, I would go probably for a rate. Let's have a look here on my calculator. If I said 186, okay, over 6 and push equals, I'm going to get 31. Now, please take note, that means 31 over 1. So my...
so that means that there's 31 pupils
so
in a
for every
class.
31 learners, there's 1 class.
So that's a rate.
That would be a ratio. But in this case, we could actually say 31 learners per class.
Which is the rate.
Which would then be like a rate.
Okay,
Actually,
well,
that was a great question.
Tapang's got a control test tomorrow, so I think that's why she was asking that.
You know, the good thing about that, what's your name?
Tapang.
Tapang, the good thing about that kind of questions is that they wouldn't normally ask you, is this a rate or is this a ratio? Okay? You've just got to be able to work with it. I'm yet to see a question saying, is the following a rate or is the following a proportion? Okay? Or is the following a ratio? I haven't quite ever seen a question come up like that before. And I've seen a lot of questions before. I think what they want to do is make sure, do you know how to work with it? Okay. But that was a great question, and I hope we've kind of answered that for you. Okay.
Definitely.
All
cool.
right.
Peter?
Anything else?
I think you can carry on for now, but don't worry, I will be interrupting you at any point to ask questions. So guys, keep those questions coming in, and I'm going to let Peter do what he does best, and that's talk loud, talk a lot, and help you learn more and learn extra.
Cool.
You know?
Let's keep going. Next question. The table below lists the various tub sizes that Vusi will be using for the frozen yogurt. So he has small tub sizes, medium tub sizes, and large. Okay? The small is 125 millimeters, the medium is 250 millimeters, and the large is 500 millimeters. Vusi estimates the various tub sizes will sell in the following ratio. 1/5 of the tub sizes will be small. 3/10 of the tub sizes will be medium, and half of what he sells will be large. If Vusi has 1,500 liters of frozen yogurt, use the information given above to calculate how many of each tub size he's going to sell. All right, now, this is fantastic. This is definitely a little ratio question. The first problem I have is this. I have different denominators here. I've got 1/5, I've got 3/10, and I've got 1/2. Let's get them to be more or less the same. Okay? So I'm going to make everything over the same denominator. In fact, when you were grade 8 to 9, you heard your maths teacher babble on about something called the common denominator. Okay? And basically what we're saying is let's get everything so that we can compare our different ratios. Now, there are 2 ways to do this. We could actually say, let's get everything over 10. Or we could say, you know what, let's change everything to a percent. Now, what is 1/5 as a percent? And the nice thing about changing everything to a percent, I think anyway, okay, is that you know everything's out of 100. So what is 1/5 as a percent? Well, on our calculator, we can say, right, we've got 1/5, 1/5, and we're going to multiply that by 100, and we land up getting 20%. So instead of saying I have 1/5 small things, we could actually say, well, you know what, that's 20% of what I sell are going to be small tubs. 3/10 we know is going to land up being 30%. How did we get that? We said 3/10 times 100. And a half will be 50%. And you see, the thing I like about changing this all to percent, you know that percentages has to be out of 100. And if we take the 20 and add the 30 and add it to 50, we actually get 100%. So it's 20, 30 is 50, and 50 is 100. So all the tubs we sell, 20% are small, 30% are medium, 50% are large. Okay, so now let's just work out how many we actually going to buy of each size tub. I'm just getting rid of that previous question. So 20% are going to be small. Now, of the litres we have 1,500 litres. What is 20% of 1,500? Okay, so we're going to say, cool, we got 20% is written over 100 times 1,500. And we're going to land up with an answer. And our calculator is going to do the work for us. Why? Because we bought this calculator, it cost us a lot of money, so let's use the thing. Okay, so it is 20% over 100 multiplied now, oops, let's just get rid of that, sorry, delete, oops, now I'm really going crazy. There we go, multiplied by 1,500. Okay, so 300 litres are going to consist of our small size. Okay, 300 litres of the small size. How many litres of the medium? Well, it's 30%. So we're going to do the same thing question again. But what we're going to do is we're going to say, right, instead of now saying we've got 20%, let's find 30%. So we're going to say 30% and percent over 100 multiplied by 1,500, and we land up then with 450. So my medium is now 450 litres. Okay? How many large are we going to say? Well, it's going to be half of the 1.5, which should give me 750 litres of ice cream. Okay. Folks, we haven't come to the end of that question, hey? And I'm going to have to speed up because my producer's saying funny things in my ears about time running out. Now, 300 litres, if we look back at our table, you will see that the small tub is made up of 125 millilitres. So how many tubs do we need if we've got 300 litres? Well, what I'm going to do is I'm going to say, right, we know each small tub is 125 millilitres. Let's take all our ice cream, 300 litres of the small tub, change it to millilitres. So I've got 300 times 1,000, so now I've got 3,000 millilitres. I'm dividing this now by 125 mils. Okay, my writing's got quite shocking since I've used this board, so I apologize to you all for that. Okay, equals. So we're going to say, right, out comes my calculator, delete. We've got 300 litres, we changed it to millilitres by multiplying by 1,000. We're going to divide it by 125 millilitres, and voila, I've got to buy 2,400 tubs of ice cream, okay, of the small ice cream. So I'm going to go and Vussi's going to go along, he's going to say, right, I need 2,400 small tubs of ice cream. How many medium size does he need? Well, again, oops, let me just go up here. The medium is 250 millimeters. So we're going to say, right, 250 millilitres. We're going to change this to millilitres. How do we do that? We multiply again by 1,000, and we get 450,000 moles. Divided by 250 moles. And we are going to say, cool, here we go, calculator come up, clear, and away we go. 450 litres, multiply by 1,000 to change it to millilitres, divide that now by 250 millilitres, and we're getting 1,800. So I've got 1,800 tubs of medium ice cream. Okay. So the next one now is we've got 500 mils. All right?
Mm-hmm.
Okay. So looking at this, 500 ml tubs, we know we've got 750 litres, and I'm going to do this quickly because my producer's saying the daftest things in my ear. I have no idea what she's talking about. I think she's babbling on something about time or saying some Valentine poem in my ear or something. I don't know.
That's exactly what she's doing.
What was that?
Yes.
Okay. So
expressing her love for you.
750 litres. We're going to multiply it by 1,000 to get it into millilitres. Divided by 500 millilitres, because each tub is 500 millimeters, and my answer is 1,500 tubs. Okay, so this answer here is 1,500 tubs. Okay, so let's just go through that again. I need 2,400 tubs of small little tubs of ice cream. I need 1,800 medium tubs of ice cream. And finally, I need 1,500 large tubs of ice cream. Jeez, that was a question and a half, eh? That was definitely a level 2 question. Why? Because, my Gideon, that involved a whack of work. All right, it wasn't straightforward, simplify this ratio. What you had to do was, first of all, you had to change everything to a ratio, then work out how many litres of each type of size ice cream container I need, and then we had to work out how many actual containers we needed. Guys, this wasn't a problem. This was nearly a career. We were nearly here all day.
Can you imagine? A whole day of pizza, everyone. Hey? Guys,
let's not be rude. I think our time is nearly up. We've got something like 3 minutes to go or something. Are there any questions out there?
Let's have a look here. Well, there's nothing but praise for you, Peter. Chris says, wow, Peter's good. And Andile has been joining us, but he's sitting with a whole group, a study group. Andile, send me pictures. Guys, if you're having study groups, send us pictures so we can put on the Facebook page.
We might even show it on the screen.
Yeah, can you imagine? We might even. Well, let me just tell you this. Danny did get a bit confused where you got the 1,500, but luckily for you, the mindsetters are awake and they are on the page. And Fielder said it was part of the question if Vusi has 1,500 millilitres. So that fire was put out.
For 1,500 litres.
Yes,
yep.
Exactly.
Okay, cool.
So we've got a whole 2 minutes. So do you reckon we could get through a question 2?
I do. I think let's just look at this. This is a nice proportion question. We haven't had a proportion question, so let's have a look at this, okay? Find the value of P. In other words, find this little boyki over here. If 480 to 200 is equal to 36 to something. Okay, so basically what we've now got to say is this. How did we get that 480 to be 36? So with my calculator, I'm going to say, all right, I had 480, and I want to get it to, what do I want to get it to? 36. Okay, so I want to get it to 36. In other words, I had to multiply it by 13.33. Now, guys, that's like very confusing. So I'll tell you what we're going to do. We're going to look at it differently. I'm going to say this. I'm going to write it like this. I'm going to say I've got 400. No, I'm not. I'm going to find a pen first before I write. So here we go. I'm going to say I've got 480, okay, to 200. And I want to get it 36 is to something. Now, the first thing I always tell my boys that I teach is this. When you want to find a lot of something, first find one. It's always easier to work with the number 1. So I'm going to say 480 is 1 is to something. Now, how did I get that 480 to 1? I said 480 divided by 480. And what I do to the one side, I must do to the other. I've got a lovely story about that, but we don't have the time.
Peter,
so, yeah.
Stop. What are we going to do? We've got about 30 seconds left, which is not enough time to finish the question. So, guys, I know Chris Bafana keeps saying that he needs a challenge. How about we leave this for a challenge, and we answer it in the next hour or so on Facebook? Are you keen?
I'm keen. I
He's
think
keen.
that might be great, because otherwise our producer's just going to cut the program and we're still going to be talking, and next month there's going to be an advert.
Okay, so I'm going to say thank you, grade 12s. Don't forget, you're on next. Grade 11s, thank you so much for a fantastic session, and watch out on Facebook for that question. Bye, guys, and thank you for a great show.